Just want to thank everybody for joining once again to our Wednesday coaching sessions here at Canary. If you joined us last week, this will be part two with Kevin Jones and David Schultz on the challenges facing digital transformation. So with that being said, Kevin, you can go ahead and take over.
Great. Thank you very much. So if you could, Sean and Kyle, please keep watch in the Q&A and chat areas for questions. And I will welcome everybody to please think about some questions you have about what we'll be going over today, especially what Dave Schultz is going to be going over on a technical side of things. He's going to be previewing or demoing a lot of the technical details of what's possible when looking at implementing a pilot project for a digital transformation. And so if you have any questions at all, please shout out via the chat or the QA features in this virtual sharing tool, Zoom, I think it is, and we will try our best to answer those. And if we can't get to them all, then we might leave a few to the end and get back to you directly. So I will go over very briefly, just for a few minutes, what we talked about in our last session. And then I'm going to turn it over to Dave, and then he's going to get into the fun technical details. This is all why we're really here. You're not here to listen to me. You're really here to listen to him and watch what he can do. So we talked last time about manufacturing challenges, and that, of course, as we all know, there are lots and lots of challenges. Things are getting much more competitive, much more expensive, limited workforce, etc. And I last time reiterated the brief conversation I had with a company that we work with, where he said, Kevin, before 2 years ago, things were a good deal easier. Now it's more expensive, more difficult, requires much more effort, takes a lot more time to do the same thing we did 2 years ago and before. And it's not all just because of the situation with the pandemic. It's a lot of other things going on as well. And when we look at when we're looking at the plant itself, a lot of challenges in detail that the manufacturers and industrial companies are trying to deal with, such as machine downtime, production throughput, quality, on-time delivery, and even to the point of recruiting new people, getting people in the door to help operate and run the company at all levels. And we talked a little bit about how do you do that? Well, you do that with data. And there were some specific examples around that. And then I cut over to talking about the value of data, where I highlighted a couple ideas where the largest valued companies in our markets these days, quite honestly, are data companies. They might do other work, but they are data companies. And a really great shining example, of course, in our area within manufacturing and industry is Tesla as a manufacturer. And I also highlighted the fact that even private equity groups, when they acquire companies, they are funding efforts to help those new acquisitions go through digital transformations, because they know, proven fact for them, that there is a ton of value in helping those companies become more data-driven. And when we look in the mirror at what we have, typically a lot of companies are looking at most of their data that's real-time being in the ERP system, but the rest of the data is not real-time. Paper, Excel, small solid data systems, all of that dark data or hidden factory data that's in the PLCs that we don't really have access to, though that it is there, and it can be really, really valuable. So most of the data that we have access to that's real time, probably about 15% or less. And then we talked about the 3-layer cake, carrot cake with the cream cheese icing, of course, and this middle layer between the business unit and the factory is full of pieces of paper. And this is where one of the biggest gaps exists in manufacturing and industrial companies today. And the idea is to help those companies become data-driven, plug everything and everybody into a network. And then at that point, all layers of the business are integrated, and all layers of the business are operating based on that data and the information from the other layers. And then stakeholders know the state of the business currently in real time, and also the future state of the business in real time. But how many of us are operating that way? Well, not very many at all. It'd be a stretch to say it's even 5 or 10% of all manufacturers are out there or truly data driven. So that means the companies need to go through a digital transformation. And then Brendan, I think is here on the line. He and I were having an email conversation recently about, well, digital transformation is kind of an overused marketing phrase. Yeah, I think he suggested digital evolution, which I liked, and I thought about data evolution. Whatever phrase we come up with to really describe this, it's moving from this industry 3.0 perspective to the industry 4.0. Industry 3.0 is automating the machines to being able to automate business processes with the data. How do you do that? Inventory the business, inventory the intelligence. This is what we refer to as our DTMA process, Digital Transformation Maturity Assessment process. One of the first things we do for a lot of companies to really figure out where they're at, where they want to go. And then the next steps are to connect everything and everyone to the network, integrate it with a unified namespace, and then getting into this iterative process for continuous iterative process for improving what we're doing and learning based on what we're doing for those projects. Feel free to reference the previous video for a lot of the other details. There's a lot of really good content there. Last thing I'll point out here is that from this effort and the work that we do, there's a lot of really good value that comes from a digital transformation. And there are things you need to have even before you start the digital transformation, which includes a digital strategy and a number of ideas we pull from ISA 95. And then the 4 technology rules, which are incredibly valuable for enabling us to pick tools and technologies and create the solutions from products like Canary Labs, as well as some of the others listed here. That they are non-proprietary technologies open to connecting to a lot of different sources. You don't have to pay an arm and a leg to make those connections, and a lot of other capabilities. Again, please go back to that other video, because it would be great, because that would enable you to go from this kind of spaghetti setup, discrete connections, to this. And then it enables you to create really nice implementations like that. Flying through everything. So, how to. We gave a preview of this last time. Now we're going to get into the fun details. Let's say we're talking about a company that you work at, which is a chemical company, and there's a tank farm. And you want to monitor those tanks and improve the quality. And specifically, you're going to monitor the temperature, the agitator blades, the volumes, levels, etc. And you're going to use that data from a remote location, connect to it securely, get that data in real time, and then be able to improve quality by looking at the historical data and doing some interesting analysis on that historical data, and also getting views of the data right now to drive alerts, notifications, etc. But you're going to start off by connecting to one tank as a pilot project. So you're going to connect to your devices, then you're going to set up your unified namespace, and then you're going to go from there. Quick overview of the architecture. And from here, I'll turn it over to Dave. Dave, you might be muted, and I'm going to stop my share.
Yeah, you need to stop sharing before I can. There we go. All right. So I'm assuming you're looking at the architecture slide again?
Yes, sir.
All right, perfect. So let's get over into it. So as you mentioned, when you do a digital transformation and you have your DTMA and that's done, you develop your strategy. And the next step, of course, is inventory your intelligence, inventory the business, and now you want to get everything connected. So we're going to start at that process of getting everything connected. And so for this, I've used an Opto22, a Groove Epic. While you could get data connected through just some I/O using a Rio, in this case, our strategy told us that long-term, we're going to want to start doing some control on what it is we're doing. So while we're getting tank level and agitator and tank temperature, we actually want to start, there's some tanks that have a steam jacket to it. We want to be able to control that steam on and off through a relay. So we're going to start off just connecting some data using an Epic, even though we're not going to be using much logic. So here you can see I've already set up some I/O. Actually did this in the pack control, but I wanted to show that you could just set up the I/O right here. And when you go into configure all of this, you just need to make sure that your state has public access to it. And you could just stop right here and just get all that I/O connected up and read everything off. But again, because I'm using some simulated data and we also knew long-term, we wanted to build in some logic control, actually set that up in the Opto22 in their pack control. So what you're looking at here is where I've actually developed that strategy, and they use what's called charts. So think of that as the rungs on the ladder. And in a good practice, you'll just do a power up that gets you to block 1, which is my control, and it'll start this chart running. And on this, I've developed some logic that's actually doing some simulation of some data. So you mentioned that we're going to start off with a couple of tanks, or excuse me, 1 tank. I actually have 2 that I developed right away that are currently active in publishing. And there's also a 3rd tank that we're going to do something with a little bit later in the video. And of course, I've also brought in the agitators. This is showing that these are turning on and off. So this is the logic that I created using the Opto script. So I can use charts using some of these other blocks here, but I tend to like to use this the Opto script because it goes a lot faster. So currently, this is the level that I'm getting right now. So here are my numeric. These are like memory tags in a standard PLC or PAC. And this is the actual IO that I'm using. This is all digital out. So I'm getting a signal to turn the agitator on and off. That's actually what we're doing. So I did create a page that showed you what these tanks are looking like currently. So within the Groove Epic, there is also their Groove View. It's their onboard HMI software that you can use to develop some pretty rich graphics. And I'm showing you that I have levels going up and down. I have the current temperature, and then the agitators are turning on and off. And I also created a chart over here at the side just to show you exactly where that is in the video itself, or where it's actually happening in terms of its actual production. So this is the setup right away. We've connected some devices via some IO on a Groove Epic, and now we're going to take that data and we're going to publish it over. So now we need to get it connected to everything else in the process. Is that making sense so far?
Yes, hunting for my mute button. So
right.
yeah, like you had said, you've set up the Epic, you've connected that Epic to the sensors, I'm assuming, in the background. You're getting the signals. You can see the data in that pack control basic tool that you were looking at. You created a logic flow there and a flow diagram with a script to process that data a little bit. And then you created the Groove View that you just had up a little bit ago. And now at this point, now that you have everything working locally on the Groove Epic, now you're going to start to publish this data out of the Groove device. Is that right?
Absolutely. So the reason why I chose this, and this gets into why we want to use technology, not necessarily solutions, is that we want to be able to publish this data and get everything connected. So for our architecture, we used a broker that supports MQTT and a Sparkplug-B specification. So we're going to set that up here in the Groove Epic itself. And there's a couple of different options that you do have when you use an Epic controller, is that I can use or publish the controller itself, or I can publish the IO itself. So if I just was going to connect some remote IO, I would just, in this device itself here, instead of using a controller, I would use the Opto MMP that's on board. But in this case, I wanted to use that strategy that I just developed and actually publish that information out. So I've already created this Epic for my what I'm going to publish. Here's my broker connectivity. So username and password. Since Dan Ryken's on the line, it is strong password in case you wanted to know. But if you're really sensitive about security, stronger password's good.
Yeah,
so this is all. Yeah, exactly. So this is the payload that I'm going to get. One thing you do want to pay attention to on your Sparkplug is that your group and your edge node IDs, those need to be unique. So these become a logical grouping. So in this fictitious example, we're using Ectobox as our the ISA 95 enterprise, and the location is going to be Pittsburgh, with, of course, our production, which is going to be the area of the plant that we're going to have. And I guess I called it production, even though this is a, it's a remote tank farm, but this is can also be used in production as well. So once that's done, I then come over to my Canary administrator, and now I'm going to subscribe to those tags. So I've used the Groove Epic to publish the data. Now I'm going to subscribe to that. So Canary Historian has a collector that supports the MQTT Sparkplug-B. I have that configured to connect into that same broker that I'm publishing to. And you can see these are all the tags that I have available. So there's a lot more information that's there. And I have only enabled certain tags to be published. So this is now going to take the data that I have set up using the Sparkplug-B. This is the data prefix. So this will be the database that it goes into in the Canary Historian. And this is the actual location I'm going to my historian that sits as part of my process. So you can see that that's all happening. Those are the tags. And once you get that all set up, you just enable that. So now it's consuming the information from the Groove Epic, and it's now pulling that in and putting that into a Canary Historian. So going back to the overview here, we've now connected to the tanks. We're now publishing it to a broker, and now we're getting Canary using that MQTT connector to consume that data. With me so far?
Yes, and when you were in the Groove, I'm just kind of referencing back a couple notes that I wrote down. When you were in the Groove Epic, you were setting up the MQTT payloads for Sparkplug-B, and then that's where, as you were saying before, you set up the group ID for the enterprise, which here in this scenario is called Ectobox, and then the edge node ID was the location, I believe, which was Pittsburgh. And then from there, at that point, you're publishing the data to the data broker. Now, this presumes that you've set up a data broker. You didn't get into that yet, I don't think.
Oh, yeah, apologies. I just, it's a broker is been set up. So that's what I'm now publishing to. I didn't think it was relevant to actually go through and setting up a broker, but understand that there is a broker that is running in the background. Where everything is connecting to that. Yeah,
just
so it's getting it
clear that it's there. Yeah, absolutely.
Yeah.
Okay, good. And then you set up Canary to subscribe to those tags, and the data is now being stored in the historian.
Yes.
Okay.
Yes. So you notice that this is now that data set that is now publishing to. It's called Ectobox, and you can actually get in here and see what tags are coming in. So go back a couple of days, and this will just tell you that, yep, I have these tags are now coming in. So here's my agitator, here's my level, and the temperature coming in from the two tanks. So IO comes in as IO, and these come in as numeric variables. That's how they get used. But this isn't the best way to use the data. I want to create some dashboards out of that. So I'm going to take advantage of a feature in the Canary Historian, and I'm going to use something called a virtual view. And what the virtual view does is that it allows me to use regex. Why they call it regular expressions is beyond me, because they're anything but regular. And I'm now going to create some additional, or put some parameters around that, so I can actually create some assets known as tank 1 and tank 2. So walking through it real fast, I'm just starting at the beginning of line. I just look for anything that's a wild card, do it a whole bunch of times, but don't get too overly excited. I don't want to put in a question mark there, so it's lazy. And I'm now going to look for anything that has io.tank with a number after it. And I'm now going to replace it. So I put in parentheses on this first one just to keep track of all my data together, just so I can keep track and make sure my regex is correct. And then when it sees a number, that sets up that set. And now all of a sudden, I've now created the tank 1 agitator, tank 1 level, and tank 2 temperature. So that's what I've done for both the IO as well as for the memory tags, or the strategy that I've published out. And I've created an asset. So what this then allows you to do is that I can come over here and very quickly, I can create an application that's now going to take advantage of that virtual view in the data set. And it's now given me a tank 1 and a tank 2. So I can immediately start trending my temperature. I can immediately, level, I can start creating or trending my temperature. I can also know the current status of the agitator, and I can also know how many times did it cycle in the last 10 minutes, how many times did it cycle in the last hour. I only had to set this up once because I took advantage of that asset. So now if I want to see tank 2, I can just click over to tank 2 because it's already been created for me. And now I can quickly view that data and its status. And you'll notice that its agitator cycles a little more often, and it has a little bit different level and temperature. Any questions on where we've gotten so far?
Let me review a couple things, but before I do, let me just ask everybody, if you don't mind, throw a quick thought here in the chat. How are we doing so far? Is this good? Is this valuable? Too fast? Too slow? Or is there something specific you'd like us to cover? So while we keep going here, I'll keep my eye on the chat. Thank you, Dwayne. We're doing good. Please, anybody else throw in a few thoughts. We'd definitely like to know if we're hitting the target here, or if we need to, pivot a little bit to go a direction that might be more valuable. All right. So with that said, we are subscribing the data, subscribing to the tags, and then creating a view. And then within the view itself, you're using regular expressions or regex to be able to process the data. Could you speak just a couple minutes about the regex and what the purpose is of that? To me, it is a way to identify patterns in the either in the data or even the names of tags, properties, all those kinds of fun things, and then be able to kind of clean them up on the fly, so to speak. How would you describe what regex does?
Yeah, so what regex is it comes out of web development, and it just uses a syntax that allows me to take this Ectobox Pittsburgh production.strategy.io.tank_1_agitator, and then I can reframe that as tank1.agitator. So this expression up here, the regex, it's now taking this data structure and it's transforming it into this data structure. So that's the syntax that it uses. And so this is looking for the .io because that's coming from the actual physical IO. This one here is looking for the strategy.numeric variables. So these again are those memory tags. And that's payload, and I'm just restructuring that to create a tank1.level, and then it will also do the tank1 temperature because those are simulated variables and values that I'm using.
Okay, good. Thank you. That helps.
Yeah, sure.
A couple of things. I'm getting some comments that we might be going a little bit fast, a little bit high, so we'll slow it down a little bit here. So I'm going to review other things.
All right, apologies. I'll get going. I know people are busy, so I'll keep moving. But if it's too fast, I'll slow down. So apologies for that.
Okay. Well, let me ask a couple other questions, make a couple points, and then I see a couple comments coming in here too that would be a good idea to address. Now, around this regular expressions, I would imagine that this would be really valuable for brownfield development. If you've got a lot of existing PLCs and crazy naming structures for tags and devices and all that kind of stuff, this is a place where you could start to clean it up to see better tag names in Canary, and then actually be able to understand what you're looking at. And it's easier then to create the views and then create visualizations in Axiom. Would that be fair?
Mm-hmm. Yeah, absolutely. So you notice that I had two different tag structures that were coming in on this. Imagine in a brownfield area where now all of a sudden you could have alarm for an alarm tag, ALM for your alarm tag, or some combination of that. That becomes very challenging to try to pull in all of this various data structure and getting it all inside of a common name format. Because again, what we want to try to do is package common data together, give it some context. And that's what we're doing here. And then finally, we've created this tank asset, which is how you get the tank 1 and the tank 2. And you'll notice there's some additional tag counts down here. It's pulling in some additional tags that came through when I was just making sure everything worked before we got live on here. So just ignore that data behind the green curtain there. Does that make sense?
Yes. A couple other questions. One comment from Dwayne. This is a good comment. Dwayne, Dave, feel free to respond to this. Seems easier than setting up a Modbus connection! Exclamation. I think that was almost a softball. Like, yeah.
Yeah. Right. Yeah. So we're going to, and they always caution you on doing things live, but I'm actually going to publish some additional data, and I'm going to show you what this is like. Instead of having to map and map and map all these various individual Modbus connectors, we're just going to create another tank number 3 in our system, and I'm going to demonstrate exactly how the rest of the system responds, because we're getting it connected, and programmatically we're able to create additional data and additional value.
One more quick thing before we move on to see
Yes.
the magic happen. Alexander is asking, what broker are we using for this? We typically or often use HiveMQ. For this one specifically, we're using Mosquito. Dave is using Mosquito just to keep things clean and is in his existing HiveMQ environment. But there's a quick answer for that one. All right, Dave, let's keep it going.
All right, very good. So I did actually use, so we're going to jump into some Factory Studio. One of the challenges that you run into is now all of a sudden we're seeing this same agitator and all these tanks coming through. So you have your IO and your numeric variables. So I'm using Factory Studio, one of their asset models, to just visualize the data that's coming in. But while Canary is able to utilize something that creates this nice little dashboard, wouldn't it be great if we could also take this same asset model and publish it back out? Well, that's a great idea. And we're going to take advantage of a Canary publisher. And you can see here that I've created another connection called Ectobox. I'm going to enable this publisher. And boy, they always caution you about doing live. So ideally, when I come back here, this should come through and we should start seeing it. It hasn't published yet, so we'll give it a couple of seconds. But you will see that this, when this refreshes, that those tanks will now be coming in that format that I put in there in the publisher. So since the magic didn't occur, let's walk back to exactly what happened here. So I'll go into the configuration of it. And so you can see I've set up several publishers. It's called Ectobox. And what I'm doing is I'm taking that view and I'm packaging it up. And so now I'm going to publish back out on a group and a node ID called a Asterion, and it's going to be in my views. And I'm going to call my device ID is going to be tanks. So I'm publishing to that same broker, and it's now going to take that exact same view as an asset. And now you're going to see tank 1 as a folder or as a topic. And then you're going to see underneath that agitator, level, and temperature.
Could you cut over to the architecture diagram just to kind of firm up what you were just talking about? So what you were talking about is in, if not Canary, maybe in some other product like Factory Studio, which is what I think of as an industrial development platform for MES and SCADA applications created by Tatsoft. In that development platform, you can also, much like Canary, subscribe to data, process that data, and then I think, if I understood you correctly, you are then publishing that data back out to the data broker. So it's like in Canary, you see the subscribe, so Canary is pulling in data, but now it's almost like you're going to make Canary push data back into the data broker, and then other systems can pull it. So here we're talking about, let's say there was another thing on the bottom right or the top right called Factory Studio. It's subscribing data to data, and then it's processing it, pushing back out, and then Canary can subscribe to that additional data that Factory Studio has created, like maybe OEE, for example.
Yes.
Is that fair? Okay.
Yeah, exactly. So there's some missing pieces here. Just wanted to demonstrate it's subscribing to data, putting it in context, and publishing back information.
Good. Awesome.
Yeah.
We're getting a couple other questions here, but it looks like maybe this, at least one of them will be addressed by getting into adding the other tank, I think.
Exactly.
Okay.
So now I'm going to come back here, and these other tanks that I've created, I have to get back in, I have to get in my configuration mode again. And so now I have to come here, and you remember earlier I talked about making it public or readable. I'm now going to we're going to pretend that these tank tags didn't exist, that I've now just added these 3 new tanks in, and I'm now going to publish them. So I just need to save the strategy. I need to push that down to my Groove Epic. I need to now start running the strategy. Come back over to my publisher, and you can see my MQTT collector or connector. Yeah, collector. I now have additional tanks that are coming in. So I now have tank 3 temperature and level and agitator is now in there. I can go into my Asterion, and I can start seeing tank 3 agitator coming in. I can go into my virtual views. I always warn you about doing this live. Oops, got a little too excited there. And there should be a 3rd tank showing up here. So if anybody from Canary wants to chime in on something that needs to happen, what should be happening right now is that tank 3 has automatically connected in. And if I were to do a refresh over here, you would actually see tank 3 show up. But doggone it, it worked great in practice.
Dave, I wonder if you maybe just want to rebuild that view real quick. Let's try that. Yeah.
hang on a second here.
While you're doing that, Dave, we're getting in some other good questions here. I'm going to get to these questions soon. And Jennifer, if you're still on, thanks for dropping by, and we can connect about some of the things you mentioned here in the comments.
Yep. Oh, there we go. There's the pro tip. So now I got 3 tanks coming into my virtual view. So, and getting a little excited. I know, right? Yeah, it's a good thing the pros were on. So now you can see I have tank 3. It's all in there. I can refresh. I now have tank 3 that I can click on. And ideally, if this were updating, I've also published that. So I should be able to now see all this information coming through, and it hasn't done it yet. So I may need to refresh this screen as well.
So let's go back to one of the prior questions, Dave, about Modbus. Seems easier than setting up a Modbus connection. So how would this, for others that don't quite get that question, how does this compare to setting up a Modbus connection? Like, what's that like compared to this?
So currently, if you're using Modbus, you have to map every connection that's there. And so if you're using Modbus, I now have to get a Modbus register. I have to get that connected and defined one-to-one. Typically, when you're using Modbus, you're now, to get it to talk to other systems, you might go into OPC. So for instance, I could have a KEP server that's running in the background that has all of my OPC tags coming from all the, say, the PLCs that are down on the plant floor. I would then have to go through, and I'd have to one by one make all those connections manually. And so what I've showed you here is that instead of mapping Modbus registers, mapping PLC tags, getting everything into an OPC server, going back into my OPC server, getting those new tags, hoping that they match the existing strategy that I've already used, I can do some management of my data. All I have to do is set up a new device. I just have to publish it to my broker. The Canary MQTT collector will then take that data, publish it to the historian, build in my asset model, and it'll take that same bunch of data and it'll publish it back out. So the difference of one-to-one mapping all the way through every piece of technology and touching it one-to-one, all I have to do is set up the tag once, which I would have to do anyway, publish it out, and then the rest magically just happens, assuming you rebuild your virtual view.
Can you go back to the architecture diagram? I'll kind of restate a little bit of that because I'm a very visual person. So if let's say we have tank 1 and 2 set up like you did, and you set up your Groove Epic with the connection to the sensors and the signals and whatnot, and then you had already set up the MQTT payload with Spark-Plug-B, set up your group ID, your edge node ID, etc., and you're publishing that to the data broker. Because you are using MQTT as defined by some of the 4 technology rules that we use, edge-driven, report by exception, lightweight, and open technology, that then pushes us towards something like MQTT or some others, not OPC UA. MQTT itself uses a publish subscribe data broker kind of idea. And so therefore, when you're pushing data into it, that data is immediately available. So as soon as you then connect the sensors from tank 3 to the Groove Epic, the data just continues through the same structure. It pushes right from the Groove to the data broker. If you were doing Modbus, you'd have to set up the stuff in Kepware, let's say. You'd have to set up those additional tags for that additional device, not only in the PLC, but also in Kepware, and then you would also have to set them up in the Canary system. Okay,
yes.
Right. So that's a huge, huge difference. And when you're talking, not just 3 systems, but 30 or 300, massive difference.
Exactly. Okay. So any device that publishes it, any device that's subscribed to it, in this case, it happens to be Canary. And then again, I did bring in Factory Studio to visualize that. It's that now those are automatically receiving the payload. So anything that is out there that is subscribing to this broker is now going to get that same amount of information. I just had to set the tag up once and publish it, and I'm done.
All right, so we've got some more questions. And everybody can feel free to hang on as long as you can. Dave, I've got time. I you've got time as well, I think. Let's keep going for some more questions, if that's okay with you, Dave.
That's fine with me.
All right. So Chris with a K had said, if you were to add, I think we've already answered this, if you were to add another data stream to your asset, that gets applied to all the assets called tank? Question mark.
Yes. So let's go back here to how I define that. So as long as it follows this data structure, it's now going to get automatically built. Now, especially in brownfields, the more stuff you add, you might run into a situation where there's something called alarm, something that's called LVL instead of level. You can have those various scenarios. But at that point, if that happens, you just need to build that definition and get it into this format. And then, once I am in this format here, where I just have tank with a number, anything after it, it's now going to assign it an asset type of tank, which is what I've done now down here.
And that's where these kinds of tools within Canary really help a lot. The views, the regular expressions, or regex, etc. Yeah, cool, good.
Exactly.
What is the best way to watchdog the service or resources to ensure that they're not down for more than 5 sample intervals or time periods?
It all depends on where the failure exists. So if, say, it's a loss of connectivity, I think we're just talking about some store and forward. There is within Sparkplug-B the concept of a primary ID. And so any technology that utilizes the primary ID, so I can actually show you that here. I'm not using it, but when I go into my MQTT collector, when I'm configuring that, let's see, I believe it is here. It's the, have to get to the right spot on where it is that I'm going. Apologies. There's a setting in here that I got to find it real fast. So primary application, here we go, right there at the top. So if I click as a primary application, what I'm publishing to, that takes advantage of a service that something in here is a primary application that is going to keep track of all of the applications that are now connecting, or all of the devices that are connected to the broker. And they will provide it rules for what do you do when there's a loss of connectivity. Do I reroute to another broker? The specification also requires you to do store and forward. So on the Epic, I do have the capability of doing a store and forward. So if it loses that connectivity, it will retain that, and it'll write to itself until that connection comes back online. You can also do things like clustering within that, within brokers. So you can actually have multiple brokers that all act as one. So if one of them should happen to go down, they'll just automatically switch over to another broker. So a lot of underlying technology. You did mention that I'm using a Mosquito broker. That's one of the features of that. Why I like HiveMQ is because its ability to cluster is very good. Sometimes when you're clustered, if it has to republish it, you'll actually get a new birth certificate that comes through. That's part of the Sparkplug-B specification. It can do that seamlessly. The HiveMQ broker can. So when it's clustered, the devices are none the wiser that there is a switch. So several ways to mitigate that.
Awesome. A few other questions, and you're actually starting to almost touch on a couple of them. This one I think is pretty straightforward. So from Chris with a C, does creating new tag names in Canary create problems with maintaining the unified namespace?
So if you're talking, I'm assuming that they're referring to how that I have utilized this publisher service.
I would assume, yeah.
Yeah. So, in here in the publisher, I'm now taking this configuration that I've called Ectobox, and it's now publishing it out to a historian and some views. So it's sort of a longer answer here, but very quickly, all I did was created a group and a node ID so that we could delineate it in for the purposes of the demo. But in reality, there's several different methods that you can utilize. For me, I would have multiple brokers that are publishing at different spots, because ideally you would want this payload to sit where it kind of made sense. So there's some more architecture that you would need to set up. So you'd have more than one brokers that are sitting at, say, maybe an area of the plant instead of just at the site of the plant. And you might even have it at the line. for that plant. So you would be able to take advantage of that ISA 95 architecture and not disrupt that unified namespace. So a little more involved. We can certainly take that question offline and walk through exactly what that would look like.
Yep, absolutely. Chris, feel free to reach out to any of us. We're happy to help further. Let's see. Craig asked, data quality status of the data received. How do you mark the data the data quality is suspect?
So when you get into what's known as QoS within the MQTT Spark B standard, is that there's something known as QoS, which is quality of service. And I have to find that here setting in here. Get it there in a second. Here we go. QoS. So there's 3 different levels that you can do. It's 0, 1, and 2. 0 means I'm going to publish it, and good luck. If you set the quality of level once, it then is to a 1. It's going to do it at least once, meaning that it's going to publish it. And if it doesn't think you got it, it's just going to continue to send it over and over and over again. The downside to doing that is that you may end up having multiple payloads that come through because it's at least once. And the consumers of that data might decide, oh, look at all this various payload. That thing just, I might get 6 values instead of the 1. And then finally, QoS2 is that, at only once, meaning I'm going to publish. And once I get back the response that says, yes, I published and it was received, then it only, you'll know that data is good. And so that's, again, part of the specification that if all of a sudden it loses connectivity, there is a little heartbeat payload that goes back and forth. It'll get confirmed in there. So, and then of course, then the last one is that you can also set up a retain flag. So at least you know what its last good value was, and you can see that. So there's some settings within the MQTT Sparkplug B specification that help with that as well.
Okay. And he had, Craig had sent in a follow-up statement, but then also said thanks, as in you're starting to answer. But he had said, and I think this is a good clarification of the question. If the instrument was bad or had bad quality, and you're monitoring the signal quality, how do things work? What happens if the signal drops below 4 milliamps, or goes negative, or goes above 21 milliamps, that kind of thing? So it sounds like you pretty well addressed that, I think, right?
So what he's referring to is within a 4 to 20 milliamp signal is that you're generally going to have error cases. Something's wrong. I'm either going to fail high or I'm going to fail low. Most of your current instruments also publish over a HART standard that brings through some of that data. So if you do have the ability to publish that HART information out, so you can get you have your PV, your primary value, you can also split that up into a secondary, a tertiary, and a quaternary values for what's coming out. So if you do have an error condition, you can fail high, fail low. It will, you can configure the system to do something. Again, it's not smart enough to be able to detect that, but you can also use one of those HART variables to publish out that, hey, I'm bad. And you can pull that data in as well.
Craig, it looks like Craig's on the same page because he agreed. Yep, fail high, fail low. So all good. Another one that came in: how do you set up the report by exception for the publish side of Databurger?
So report by exception is really driven by the device itself. And so, again, when you first publish a payload, it's going to publish in everything that is part of its data set. So let me go back here to the tags. When I first publish this information, this entire data set gets published if I have it enabled. And you can see this is the data set that you would get if had this, if I were able to show that view occurring. But when anything new shows up, it's going to publish its entire payload. From there, it only publishes something that changes, and you define what that exception case looks like. So in some technologies, you do have the ability, much like a historian, like the Canary, if it doesn't change more than a certain amount, I'm just going to continue to assume it's within a certain range. And that's how you can minimize it. But again, when it sends out the debirth, it sends its entire payload. And then after that, report by exception is just a fundamental piece of the MQTT Sparkplug-B specification.
Yeah, that's where I was going to start, is that just by the nature of using MQTT, it is report by exception, but then you can get to a level deeper to set the conditions for what you are monitoring to, what that exception is, what value changes, et cetera.
Exactly.
Yep, good. Makes sense.
Yeah. There's a lot that's built in for handling those types of things.
Good.
Again,
And,
Spark-B specification was designed for automation.
yeah, good. And going back to the conversation with Craig around quality of signal and data and whatnot, Chris threw in an additional comment, I think that's related to that, which is most PLCs should have an analog out of range alarm bit as well.
Yeah.
Just a quick comment that's helpful there. Good.
Sure.
All right.
Yeah,
I think we've covered all of the questions. Is there anything that we have not covered, Dave, that you think would be useful? Or Sean, Kyle, any additional comments, thoughts we could cover at this point? I think we've been pretty darn thorough.
Yeah, I think you guys covered quite a bit. And definitely appreciate that. This has been a great mini series you guys have put on.
Awesome. Good.
Yeah. And you can see this little bump where I published that third tag now. So there's a little hole in the data.
Awesome. Cool. Yeah. Okay. Sean, Kyle, thank you so much for having us. We really appreciate it. Everybody who was able to stick around the whole time, thank you so much. Great questions. This is awesome. We love doing this kind of stuff. If anybody has ideas on other topics that we could cover in and around Canary and this whole, unified namespace, digital transformation, data-driven architectures, designs, technologies, all that kind of stuff, please throw over some emails, comments. We'd love to hear them. We'd love to do more of this.
Yeah, we'd love to have you guys back again. Definitely. This has been outstanding. Yeah, thanks again, guys.
All right, thank you. Well, thank you, everybody, for jumping on today.
Yep.
Thank you.
Take care.
All right. Everyone have a great remainder of your day.